I welcome you to my YouTube channel. In this video, I am going to teach you how you can name one additional complex. Rule number one, you have to first begin with the name of the cation before you name the anion. So whenever a complex is given, whatever you write first is your cationic part. Then we have to write anionic part. Clear? Now I have to name the cation. K is potassium. So the name should begin name of the cation. Rule number two, when you name the complex, the names of the ligand should be written first while you name the complex. So here you have the complex. Immediately after writing the square bracket, you have central metal atom. But while you name it, the name of the ligand should be written first. Keep it in mind. But if you have more than one type of ligand, in such cases, you have to follow the alphabetical order. So this is the rule number two. Clear? If you have only one type of ligand is present, such complex we can call it as homoleptic complex. Homoleptic complex. Got it? Let me move on to the next. When you name the anionic ligand, so here Cn minus. If minus is there, this ligand we call it as it is anionic ligand. Clear? The name of the ligand, anionic ligand, should end with O. So what's the name of this Cn minus? It is actually cyanide. This ends with IDE, cyanide. That suffix have to be changed into cyanido. If you have a name ends with ite, the suffix has to be changed to ito. Remember, and if the name ends with ate, the name has to be changed into ato. Clear? So I have given the list. So bromide, it's having a negative charge. Bromide has to be changed into bromido. Chloride has to be changed into chlorido. Cn minus cyanide has to be changed into cyanido. OH minus hydroxide has to be changed into hydroxido. O2 minus oxide has to be changed into oxido. Fluoride F minus changed into fluorido. Carbonate CO3 2 minus changed into carbonato. C2O4 2 minus oxalate changed into oxalato. SO4 2 minus sulfate changed into sulfato. Thiocyanate SCN minus changed into thiocyanato. Thiosulfate S2O32 minus changed into thiosulfato. Sulfite SO32 minus changed into sulfito. Just remember this. If you have any anionic ligand, the name has to be end with O. So here I have cyanide. Since it is an anionic complex, the name I have to change into cyanido. Got it? Okay. Now, if you have in your complex, if you have any neutral ligand for which there is no charge, so they have to be given its usual name that has to be given by its usual name. Example, ethylene diamine. There are some exceptions also. If you have water, for water, you have to give special name aqua. Ammonia, NH3 for NH3, you have to give special name amine. Carbon monoxide, you have to give carbonyl. So these three neutral ligands come often. The next point, if you have more than one ligands of same type, so you need to indicate the number of each type of ligand in Greek prefixes. You have to use di for 2, tri for 3, tetra for 4, penta for 5, and hexa for 6. In our case, this Cn minus comes 6 times. For 6, we need to use hexa. This has to be written before the name of the ligand. So what I have to name here, I have to write before the cyanido, I have to write hexa. So what I have written so far, I have completed naming cation part, and then I have named a ligand. So when don't forget, when you write the complex, the ligand name should be written first, followed by I have to write metal name. So now let us see the rule number 3. When you name the complex, if the complex is anion, if you have the complex having anionic part, what you need to do? Let us now see rule number 3. When you name the complex, on the complex, if you have any negative charge, such complex we call it as anionic complex. Then the central metal atom or ion, that name should end with ATE. Don't forget, it is most important one. If you have the transition metal scandium, if it is present in anionic complex, the name should end with scandate. See what I am doing here? I am removing IUM. It is replaced with ATE. Titanium, titanate. Vanadium, vanadate. Chromium, chromate. Manganese, I am replacing ESC with ATE. Iron, here iron is ferrum. What we do? We are replacing UM with ATE. Cobalt, cobaltate. Here I don't have anything to remove. Nickel, nickelate. Copper, cuprate. Why cuprate? Here copper is called as cupra. So you need to remove UM with ATE. Zinc, zincate. Right? Now, in our case, consider that complex we have taken. Here it is that we have taken K4, FeCN6. First part is our cation part, second part is our anion part. On this complex, we have negative charge, so the name of the metal should end with ATE. Got it? Now, the foremost thing is to find the oxidation state. So you have to find the oxidation state of metal. How we can find? So here it is a complex. On this one, the charge we have is 0. So what I have to find? I'm going to find the oxidation state of metal. So what rule I'm going to follow? Sum of all the charges should be equal to sum at the top. So what I can do? 4. I have 4k, each k having plus 1 charge, plus I have only one Fe. I want to find the oxidation state of Fe. That's why I have written X, plus I have 6 cyanide, each having minus 1 charge. The sum of everything should be equal to 0. Clear? Now I'm going to simplify it. 4 plus x minus 6 is equal to 0. X minus 2 is equal to 0. Then x minus 2 is brought to the other side, becomes plus 2. So now I have got the oxidation state of metal is plus 2. That has to be written within the parenthesis. So this one, what we call parenthesis. Okay. So within that, I have to use capital letter, no Roman numerals must be written. Got it? Okay. So that is why I have written like this. Thanks for watching.